Hello, welcome to Chapter 8. Today we are going to be working on Lesson 6 called Comparing Fractions. Let's get started with one of our definitions here. The least common denominator, LCD. Very similar to LCM, least common multiple, of the denominators of the fractions. You can use the LCD to compare fractions. So for this one, we're finding least common multiple, but we're just doing it with the denominators is the only difference here. So let's get started. Trevor made 2 out of the 3 goals, and Tyler made 5 out of 6. Who made a greater fraction of goals? Okay, so we have 2/3, 2 out of 3, and we have 5/6, 5 out of 6. So I'm going to look at my denominators 3 and 6, and I'm going to try to find the least common multiple so that I can get those common denominators. Okay, so if I count by threes, 3, 6, you can see where this is going. Look at that, 6. So the LCM of 3 and 6 is 6. Find equivalent fractions is our step 2. Find equivalent fractions with a denominator of 6. So we want our denominator on both fractions to be 6. In order to make this 3 a 6, I need to multiply by 2 over 2. So notice how I'm taking 2/3. This is how you will show your work on your notebooks or in your books when you're doing your work. And I'm going to multiply by 2, multiply by 2 to get 4/6. Okay. And 5/6 already has 6 as a denominator, so I don't need to do anything with that one. They show multiplying by 1, don't waste your time. Just write 5/6 because it's already what it needs to be, okay? So I have 4/6 here and 5/6 here. I know that now they're the same size of a piece. They're both 1/6. Here I have 4 of them, and here I have 5 of them, okay? So since 4 is less than 5, I know that 4/6 is less than 5/6. And really, I shouldn't be writing in 4/6 though. I should be writing in the original number that we were talking about, which was 2/3. 2/3 is less than 5/6. So 2/3 is less than 5/6. So blank, who made the greater fraction of goals? That would be Tyler. And notice, we can check our work with fraction tiles. Now, if we were in school, we'd get these out, but we'll have to make do here. So I have 1/3 plus 1/3, which would make 2/3, and then I have 5/6. So you can notice too with the fraction tiles, the picture of them at least, that 5/6 is bigger. Let's read our helpful hint. Multiplying the numerator and denominator by the same number is the same as multiplying the fraction by 1. That's why we can do it, because we know if we're multiplying a fraction by 1, we're not changing its value. Okay, and that's the big thing. When we're talking equivalent fractions, they all have the same value. And that's why we can do it, because we're just multiplying by 1. The result is an equivalent fraction. Equivalent just means equal value. Okay, so let's do another problem. Compare 3/5 and 1/2 using the least common denominator. Okay, so let's count by 5s. 5, 10. Now I know 2 goes into 10, so I'm going to list my multiples of 2. 2, 4, 6, 8, and 10. Okay, so 10 is my least common denominator, least common multiple. So I want the denominators to both equal 10. So I'm going to take 3/5. And I know if I multiply 5 by 2, I'm going to get 10. Then I have to do the same to the numerator, because we know that 2 over 2 is just, look at this fancy little thing, it's just multiplying them by 1. Right? Like if I was going to visualize 2 out of 2, it would be like a pizza that I cut in half, and I ate both pizzas. I ate one whole pizza. Right? If I cut it into 4 pieces and I ate 4 pieces, I ate one whole pizza. If I cut it into 8 pieces, I ate one whole pizza because I ate 8 out of 8. Okay? So we're just multiplying it by 1. So 3 times 2 is going to get me 6. I'm coming back over here. 2, I have to multiply 2 by 5 to get to 10. Do the same to the numerator. 1 times 5 is 5. Okay, so I have 6/10 and 5/10. We know that 6/10 is bigger than 5/10. So if I go back to the original fractions, 6/10 is equivalent to 3/5, and I know that 6/10 was the bigger one. 1/2 is 5/10. And notice for 1/2, 5 is half of 10. 1 is half of 2. So that's a quick way to figure out if it's 1/2 or not, is if I have like a denominator of 16, then half would be 8. 8/16 is worth 1/2. If I have a denominator of 40, then if my numerator is 20, that represents 1/2. Okay? I think that's all we can check using the models. So here I have 1/2. Notice it's the same kind of size of chocolate bar. I always like to think of the fraction strips as chocolate bars. And then I have 3/5. So I have 3 pieces on there out of 5 total, and here I have 1 piece out of 2 total, 1/2, and 3/5. So we notice too with our models that 1/5 or 3/5 is bigger than 1/2, just a little bit though. So that's why it's always good to do the math so we can prove it. Let's go to the next slide. Here we are going to compare 1/5 and 1/3 using the LCD. So if I count by 5s, 5, 10, nope, 3 doesn't go into 10, 15, yep, 3 does go into 15. So 3, 6, 9, 12, 15, here's where they converge, here's where they meet up, match up. Okay, so I know that 15 is the least common denominator. So what do I need to multiply 5 by to make it 15? 3. So I'm going to do 5 times 3 is 15. 1 times 3, I have to do the same, is 3. Here I have 3, so I have to multiply by 5 to make 15, and then I multiply the numerator by the same. 1 times 5 is 5. Okay, so I'm working with 3/15 and 5/15. 5/15 is bigger, so that means that 1/3 is a greater fraction. Explain how the LCM and LCD are alike, and how are they different. So, least common multiple, I mean, that is, the least common denominator is the least common multiple. They're just kind of different because we're only using the denominators to find the least common multiple. That's what I would say, I guess. But they're really the same thing. Right, we're finding multiples of the denominators, we're seeing what they have in common, and so we should be good to go with that one. Let's do another problem here. Compare each pair of fractions by drawing models or using the LCD. Use the symbols greater than, less than, or equal to. Okay, so I'm going to find the least common denominator between 4 and 8. 4, 8, well, it's going to be 8. Okay, least common denominator is 8, so I'm going to take 3/4. Pay attention how I'm showing my work because this is what I'm going to expect from you. So I have to 3/4, I have to multiply by 2, and it's going to equal 6/8. And I'm going to be comparing 6/8 to 7/8, and I'm going to notice that 7/8 is the bigger one. Okay, and the reason why we need to get common denominators is because the denominator really tells what size it is. So we need to have common sizes to compare them. I can't compare like 1/2 to 1/10 because they're different sizes of pizza or different sizes of chocolate bar or whatever. Okay, so we really need to get those common denominators to be able to compare. So here I have 1/3 and 3/9. Okay, I'm going to see what would happen if I simplified 3/9. Divide by 3, divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3, 1/3. Look at that. 1/3 and 3/9 are equivalent fractions. Now I'm going to draw a model to show why. Okay, so here's my circle. Now thirds are a little tricky to draw. That's usually how we draw it, kind of like a peace sign, but they need to have, remember, pretend like all my little pieces here are equivalent, are equal. Okay, so if I color 1/3, I would be eating this much pizza or pie, whatever you want to call it. Now, let's see what would happen if I divided each slice into 3 different pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So before I cut them into smaller pieces, I was eating 1/3 of the pizza. Now I'm not going to color anything else in, but I'm eating 1, 2, 3 slices out of a total of 4, 5, 6, 7, 8, 9. There's a total of 9. I'm eating 3/9 of the pizza just because I cut the pieces smaller to make 9 total pieces. Okay, so when the denominator keeps getting bigger, the slice of pizza is getting smaller. Because I have the same pizza, here I have 3 slices, here I have 9 total slices in that pizza. So if I'm going to make 9 total cuts, I have to have a smaller piece. Okay, so that's why these two are equal. They mean exactly the same thing. All right, let's take a look at this one. Let's get common denominators here. 4 would be 4, 8, 12, 16. Let's do 3. 3, 6, 9, 12. Okay, we wanted to both equal 12. So I'm going to take 3/4. I have to multiply this by 3. Multiply the numerator by 3. And I would get 9/12. Then let's compare 2/3. 2/3, I have to multiply by 4. Multiply by 4. I would get 2 times 4 is 8. 3 times 4 is 12. Okay, because my goal is to get the denominators to both be 12. So, let's compare 9/12 to 8/12. We know that 9/12 is bigger, which means that 3/4 is the bigger fraction. Okay, and I proved it because I got common denominators. All right, that's all I have for you today. Thanks for watching.